Okay, besides the lunar phases, if you watch the moon over the course of the month, you should also notice the following. Regardless of the time of the month, regardless of the phase, the moon always presents the same side towards the earth. That is, we always see the same side of the moon. This is referred to as the near side of the moon. You never see the other side of the moon. That's referred to as the lunar far side. This is an observational fact. So then the next question becomes, okay, well then, does the moon rotate? The answer to that question is yes. However, as it does rotate, it does so in a specific way. Here's how I model this as a simple demonstration. So picture the box that I have here sitting on my stool as the Earth, and then I'm going to be the moon. I'm going to be in orbit around the Earth. However, let's initially say that I do not rotate on my axis as I do. In other words, with respect to the classroom, think of the classroom as the background stars. I'm always going to be pointed in the same direction, say like so. And then watch what happens as I always point in this direction, but I orbit the Earth. Notice that from the box's perspective, as I orbit the Earth, if you were sitting on the stool where the box is located, you would eventually be able to see all sides of me as I orbit the Earth. However, instead of that, what I'm now going to do is rotate on my axis, but I'm going to do so in a specific way. I'm going to rotate on my axis such that the rate of my rotation is the same as the rate of the orbital motion about the Earth. In other words, the time necessary for me to rotate on my axis is the same thing as the orbital period, the time necessary for me to orbit the Earth. I'm going to do so in demonstrating in the following manner. So as I do this, I'm rotating on my axis as I do, but I'm rotating on my axis, completing one rotation for every orbital period that I make, thereby presenting always the same side towards the Earth. This is what the moon does. This is an effect of the force of gravity. It's referred to as a tidal lock. The moon is tidally locked to the Earth. This is not an unusual situation. It usually occurs when you have a relatively small object in orbit around a much larger object, and the distance between the two bodies is not all that great. So for example, there are a number of moons of Jupiter that are tidally locked to that planet. The planet Mercury itself is tidally locked to the sun, and so on. So in the case of the moon is tidally locked to the Earth. Okay, that concludes this demonstration. As an accompaniment to this demonstration, make sure that you also watch the screencast on what is referred to as the moon's libration.